Hey guys, welcome to the DevOps Pro English channel. In our last video, we learned about the concept of variables and created a variables.tf file. In that file, we declared a variable named CIDR and assigned it a default value. We also discussed how to assign values to variables in the real world by creating a Terraform.tfrs file and providing a value for our CIDR variable. This is part 2 of our variable series, where we will dive into the concept of data types. We will explore what data types are, their use cases, and how many types of data types exist. We will cover all of these in today's video. Just like in our last video, where we used a variable var.CIDR to store the CIDR blocks for our AWS security groups, today we will use a variable to store the name tag for our AWS instance resource. User will provide the value for this variable to specify the name they want for their EC2 instance. So let's start by defining this variable in our variables.tf file. We will name this variable instance_name, and we will use this same variable to set the name tag. So far, we have declared the instance_name variable, and we want users to provide the value for it. In other words, user will tell us what name they want for their EC2 instance, and Terraform will create the EC2 instance on AWS with that name. However, when the user runs the Terraform plan or Terraform apply command, Terraform will prompt the user for the value of the instance_name variable. This allows the user to specify the name they want for their EC2 instance. Here, the user has complete freedom to enter any name they desire for the instance. Or in other words, they are free to provide any value for this variable. So, when the Terraform command asked for the value of the instance_name variable, the user entered 1234 as the value. And Terraform executed the command and used 1234 as the name for the instance. However, this is not what we wanted. We aim for the instance_name variable to have a meaningful value to represent the purpose of the EC2 instance. For example, if the instance is meant for deploying a web application, its name should be something like web_instance. Similarly, if it's for a database deployment, the name should be database_instance. In other words, we want the EC2 instance to have a meaningful name rather than just a random number with no significance. But neither Terraform restricts our user for entering a number as input for the EC2 instance name variable, nor we inform the user about the type of value we expect for the instance_name variable. In this case, users have complete freedom and they can input any value into this variable. And by taking incorrect values as input for variables does not give any meaning to our Terraform configuration. That's why it's crucial for us to impose some restriction or inform the user about the values we expect from them. This is where the concept of data types for variables comes into play. First, let's understand what data types mean. Data types refer to the kind of data we are expecting from the user as input. There are different types of data types. The first one is number. In the number data type, we expect the user to provide a numerical value as input. The second data type is string. In the case of strings, we expect the user to provide a set of characters as input. It could be a name or even a lengthy paragraph. We use the string data type for all such scenarios. The third data type is a list. In the list data type, we work with a collection of values. This list can contain elements like numbers or strings. For instance, if we have multiple users and want to create a list of their names, we call it a list of strings because all the elements in the list are strings. If we create a list of users' ID, it would be called as list of numbers. In this way, the list data type can be used to make a list as input. The crucial aspect of list is that all the elements within a list are of same data type. In other words, if you create a list of a string, all the elements in that list will be strings. And if you create a list of numbers, all the elements will be numbers. The last data type is our map, which is also referred to as a dictionary. In a map, our data is organized into key value pairs. For example, at some point you must have filled out a form where you had to provide your first name, last name, phone number, email address, and much more. In this context, the values you see on the left hand side are called keys, and their corresponding values on the right hand side are called the value of that key. And that's how we create sets of key value pairs. This kind of data is known as map or dictionary. So the major data types we have discussed are number, string, list, and map. Now let's move on to using these data types within the context of our Terraform configuration. In our securitygroup.tf file, we have defined rules for creating security groups on AWS. You can see that there are many values hard-coded here, such as ingress port numbers. To make our configuration more flexible, we will start by creating variables for all these values and will receive them from the user. So in our variables.tf file, we will create 4 variables: port number 1, port number 2, port number 3, and port number 4. We will specify the type of these variables as number so that we can receive numeric values from the user for these port numbers. Once we have defined these variables, we will use them within our security group resource to set the port numbers dynamically. After all of this is done, we will proceed to run Terraform plan. As soon as we run the Terraform plan command, it will prompt us for the input values of the port numbers. So let's start by entering a correct port number here, such as 8080. Once we enter the value for the first port number, it will again ask us for the input. Here we will again provide the correct value for the second port number, which is 9090. Now for the third variable, we will intentionally enter an incorrect value. In this case, we will replace the number with something random like ABCD. And for the fourth variable, we will also input an incorrect value, again using ABCD. After the Terraform plan command has run, you will notice that we receive an error message indicating invalid value for input variable port number 3 and port number 4. It states that unsuitable values were set for variable port number 3 and variable port number 4 using an interactive prompt, and a number is required. This means that we have entered incorrect values for variable 3 and variable 4, which should have been numeric. By specifying the type of a variable, we can restrict the user and inform them about the expected values to prevent them from entering incorrect values. When we define variables, we can also provide descriptions for each of them. For example, for our variable representing port number 1, we can add a description like enter a number for port number 1 in the description field. This description will be visible to the user to help them to read and understand the purpose of variable and the type of value we expect from them. Now, let's talk about the string data type. Within our security group resource, we have a name field, and inside the tag block, there is a name as well. We will use a variable to obtain both of these values, and this variable will be of string data type. Users will input its value, and Terraform will use that name to create the security group. So we define a variable called sg_name, and in its description, we write enter a name for the security group to specify its type as a string. After defining this variable, we will use it within our security group name. After saving all these changes, when we run Terraform plan, it will first prompt us for the values of all the port numbers. After providing these inputs, it will then ask us for the security group name. Here, we will enter a valid name for the security group and will let the plan process complete. If you don't enter a valid name here, such as entering a number, Terraform will generate an error. You can try this out to see it in action. However, as we have entered a valid string input for the security group name, our plan is showing us that everything is proceeding successfully. The security group is being created with the name we provided. This is how we can use the string data type. Now, let's discuss the list data type. If you look inside the variables.tf file, you will notice that we have created 4 separate variables just for port numbers. It doesn't look very organized, especially since all these variables have the same data type, which is a number. So why not create a list that contains these port numbers to make it easier to manage? Let's go ahead and create a new variable within our file named port_numbers. In its description, we will write enter 4 port numbers for inbound rules. So users understand that we want them to input port numbers for inbound rules for the security group. Its type will be a list, specially a list of numbers, which we specify as list, and within brackets we write number. For now, let's comment out the previously defined variables for the individual port numbers. So we have defined our port_numbers variable as a list, and now the question is, how do we use the port numbers present in this list? So let's concentrate on the concept carefully to understand this. Imagine that we have our port_numbers variable and it's expecting us to provide a list of 4 port numbers. For list, we use square brackets and we need to enter 4 port numbers here. So for now, let's enter some random port numbers inside this square brackets. This will create a list containing 4 port numbers. Now the question is how to use them. Similar to how we have used simple number and string variable before with var.variable name, we will do the same thing here. We will write var.port_numbers. However, there is an important difference. Since we have values in a list and we want to access a specific element from that list, we need to specify the index number of the element we want to retrieve. In other words, we need to tell Terraform which number is associated with the element inside the list, and we call this number the index. And within a list, index numbers start from 0. This means that the index number for the first element inside our port_numbers list will be 0. The second element will have an index of 1, the third will be 2, and the fourth will be 3. So, when we want to use a specific element from the list, we need to reference it by its index number. For example, if we want to access the first element, we would write var.port_numbers and 0 inside the square bracket. If we want the second element, we would use var.port_numbers and 1 inside the square bracket. For the third element, it's var.port_numbers and 2 inside the bracket. And for the fourth element, it's var.port_numbers and 3 inside the square bracket. It's important to remember that list indexes start from 0 and you use these indexes to fetch values from the list using the variable. Now, I hope you understand how to access values within the list. So in our security group file, whenever we have port number 1, we will replace it with var.port_numbers and 0 inside the bracket because our first port number is at index 0 in our list. For the second port number, we will write var.variable name, and inside the square brackets, we will use the index number 1. Similarly, for the third and the fourth port numbers, we will use index number 2 and 3 respectively. In this way, whenever we need to use element from our list, we will use the variable with the appropriate index number. Now, let's save this file and run Terraform plan. When we do this, the first thing Terraform will ask is for input for the port_numbers variable, which is a list. Since this variable is a list, we need to provide its value inside square brackets, with each port number separated by a comma. So we will enter 4 random port numbers here. After specifying the list, Terraform will then prompt us for the name of our security group. We can enter any name here and then we can let the command run. As soon as the plan is generated, you will notice that the port numbers we provided within the list are being used in the same sequence within all the ingress blocks. Additionally, the security group name we entered as input is also being reflected in the plan. In this way, we can create a list variable and use its values based on their indexes. Now let's talk about the last data type, which is the map. This is also known as dictionary, where we store data in the key value pairs. To use the map data type, let's go to the ec2instance.tf file, where we are creating an AWS EC2 instance. Here we will declare a variable of type map, and this variable will be used for our EC2 instance type. Let me explain briefly how we will use the map variable within the instance type and what its purpose is. We want to select the instance type based on the specific purpose for which our EC2 instance is being created. In other words, if this instance is being created for web application, its instance type should be T2 Nano. If it's for database, the instance type should be something else. And if it's for specific DevOps tasks, the instance type should be something different. So our purpose here is to create a map variable for the instance type. And to help you understand it better, we will declare this variable right here in this file. This way, you can easily grasp how we use a map variable. First, we will create a variable for the instance type, named instance_type_map. Its type will be map, and within the map, we need to specify what type of map it is. Just like we mentioned for list that they contain numbers or strings, here we will specify that this map will contain strings. This is because we are going to choose instance type here. So in the type field, we will write map and a string within the brackets. For simplicity, we will also provide a default value for this variable. Since maps consist of key value pairs, on the left hand side, we will define the key, which signifies the purpose of the instance, and on the right hand side, we will specify the instance type corresponding to that purpose. Let's say, for example, that if our instance is for web application, then in that case, our instance type will be T2 Nano. For the second key, let's call it DB. That means our instance is meant for a database. So in the left hand side, we will write DB as the key, and on the right hand side, we will set the instance type to T2 micro for the database related instance. For the third key, let's add DevOps. This means our instance is being deployed for DevOps related work. And for this type of instance, we want to set the instance type to T3 micro. This way, you can add multiple key value pairs inside the map according to your purpose and requirements. For now, let's keep these 3 keys, web, DB and DevOps, in our map along with their respective values, which are the instance types written on the right hand side. So we have declared a map like this and provided default values. Now let's see how we can use the values from this map. To use the values provided in this map, we will make use of our AWS instance resource and fetch the value of our instance type from this map variable. Here we will write var.variable name. Since our variable is a map with the different keys and their respective values, we need to specify which key we want to use to fetch the value. So in this way, we fetch value from the map by providing its respective key. For instance, if my instance is meant for a web application, then here in the variable would write web within double quotes inside square brackets. This will set our instance type to T2 nano. But let's see this in practice. For that, we will run the Terraform plan command so you can better understand and learn from it. Before running it, let's comment out all the variables we have created and as well as the code in our security group file. This way, we can focus on understanding the EC2 instance and our map data type. Now, when we run the Terraform plan command, you will see in the plan output that our instance type is T2 nano, which is what we specified for our web application instance. This is absolutely correct. Similarly, if we change the key to db within the variable and run the Terraform plan again, we will see that this time our instance type is T2 micro because that's what we declared within the variable. Likewise, if you use DevOps, you will find that the instance type is 3 micro. So this is how we can declare a map variable and use its values by specifying the respective keys. So that was our explanation of the map data type. If you have any doubts about any data type or any other related concepts, please let us know in the comment section. You can find all the code in our GitHub repository and we will also provide the link in the description box. If you found this video informative, please like it and support the DevOps Pro English channel. Share it with as many people as possible who want to understand concepts related to Terraform or DevOps in an easy way. If you want to watch the video in Hindi, you can find the link in the description box where you can comfortably watch it in Hindi. So far, we have created various videos, including ones about Kubernetes and the one we are currently working on about Terraform. If you want shorthand notes for every topic we have covered, you can purchase our membership plan, which is present on DevOps Pro channel, where you will have access to notes created specifically for easy recap of each topic. Additionally, you can join our Discord server and become a part of our DevOps Pro community. With that, we conclude this video. See you in the next video with another exciting topic. Thank you.